Okay, guys, so today we're going to start talking about imaginary and complex numbers. In the last unit, if we ran into a situation just like this one over here, and we went to go solve it, you would go ahead, try to take the square roots of each side. And I would tell you can't take the square root of a negative number, and our answer was no real number. There is an imaginary number I, which, by the way, does actually exist and is used in real world problem solving. The main way it's used is in electric circuits and stuff like that. I don't fully understand it, but I know it is worked there. This will allow us to take the square root of a negative number. So this letter I is the square root of -1, which means that I is the answer to the square root of -1. So if I said x squared, well, I guess we'll do this on the next page. So simply by accepting that I exist, we're able to solve problems that we weren't able to solve. So let's give some of these a try. If I look at the square root of -1, I know that the square root of -1 is I, so we're just going to put down I. Notice this part of the directions here. Since we are not solving an equation, we're not looking to solve for x, we only need the positive root here. Square root of -25, well, 25 is a perfect square. So that's going to be 5i, because this number here is really 25 times -1. And you take the square root of both sides. Square root of 25 is 5. Square root of -1 is I. Same thing here. If we're looking at this, you see the negative. I know the negative is going to require that I. And 121 is also a perfect square, so we get 11i. Sometimes you're going to have to simplify your radical sum. 20 can be broken up into 4 and 5, 4 being the perfect square. So we take the square root of that, we get 2, but let's put the negative on this 4. So it's going to be 2i, and then we still have the square root of 5. -48 can be broken up into -16 times 3. -16 is the perfect square. So when we take the square root of it, we get 4i root 3. 54 can be broken up into, let's see, we want a perfect square, -9 times 6. We've got a perfect square here, so we could take the square root of that one, and we get 3i root 6. Let's try a little bit more. Sometimes we might have some numbers on the outside that we want to deal with. So this negative really means -1. The square root of -1 is I. So this would get us -I. We're going to just bring down the -3. The square root of -25 is 5i. And then when we multiply the two together, we get -15i. Over here, we bring down the 2. It's on the outside. 16 is a perfect square. The negative indicates to us that we need the I. It's going to be times 4i. And our final answer, when we multiply these guys together, will be 8i. Try just a couple more. Now we don't have perfect squares, but that's fine. The 4 will come down from the outside. We're going to split -12 into -4 times 3. It might help to circle the one that's the perfect square. That's going to get us, when we take the square root, 2i. This guy will remain in the radical of 3, radical 3. We can multiply these guys together on the outside, and we get 8i root 3. This negative really means a -1. I'm going to break 72 into 36 times 2, -36 times 2. This guy here is the perfect square. So it's going to be times 6i. This piece I cannot take the square root of, so this one's remaining in the radical. So times root 2. That's going to be minus 6i root 2. And the last one that we have here, let's see, we've got the -3. We'll bring that down. -20 can be broken up into -4 times 5. -4 is a perfect square, so we can get him out of the radical box. He's going to be times 2i. The 5 stays inside because it's not perfect. Multiplying these guys together, we get -6i root 5. Okay, so that's simplifying the radicals with the i's, which brings us to our complex numbers. And complex numbers just have two parts to it. It has a real part here in blue, and then an imaginary part, the bi. I again representing the square root of -1. Complex does not mean complicated. It just means there's a real part and then there's an imaginary part. So here we have a complex number, 3 plus 2i. The real part doesn't have the I, so it's 3. The imaginary part is 2, and then I is just I. I don't love this piece here. I'm going to take this out of the video. We'll just go to the next one here. Let's go. I don't want to record this, but let's just go to our own chart and figure this out. So here's a complex number, 6 plus 4i. The real part is 6. The imaginary part is 4i. And this is a complex number. It's not purely real or purely imaginary. Over here, we also have a real part, -1. The imaginary part has the I. When I look at this number, it's also complex. What it's really saying is plus 0i. There are no i's. So the real part is 10. There is no imaginary part, so this part just doesn't even exist, which makes this a pure real number. It has no imaginary part to it, so it's only real. This piece over here, it's really saying 0 plus 6i. So this part, the real, it's not applicable to this particular complex number. The imaginary part's 16i, so this guy's going to be pure imaginary. No, out of space there. Here we have a real part of -12. The imaginary part is 7i. It's a complex number, so it's not either pure or not. Over here, -8i, we have no real part, just the imaginary. So this is going to be pure imaginary. 142 doesn't have the I, that makes it the real number. We have no imaginary piece to it, so this guy is a pure real number. Okay, so let's see what we can do with these complex numbers. We can add and subtract them, so we'll just start with adding and subtracting. You want to add the real numbers to real numbers and add imaginary numbers to imaginary numbers. So kind of treat the I as if it was like an X in an algebraic expression. So adding the real parts together, 3 plus 1 gets us 4. Adding together the imaginary parts, 2i plus 7i gets us 9i, and we've added our complex number. I'm adding the complex numbers here. Again, we add the real parts. So 3 plus 4 is 7. 5 minus 3i would be plus 2i. And you're done. All right, so let's give this a little bit of practice. Adding the real parts together, we get 11. 8 plus 3 is 11. Adding the i's together, 1i plus another 7 i's would get us a total of 8i. Let's try this one. 8 and -3, well, it's going to leave us with a positive 5. -2i, positive 4i, there's more positives. 2 will cancel out, so this is going to be 5 plus 2i. A few more examples here. If you see this negative, what you want to do first is go ahead and distribute the negative through. So you're going to take an extra line here before we start combining up like terms. A negative times a negative is a positive. A negative times a positive is a negative. Combining up like terms, positive 7, positive 3, always looking at the sign in front gets you 10. -6i, -9i, again, looking at the signs in front, combining those up, we get -15i. Again, if there's a minus, it's really my suggestion to go ahead, do the distribution, take that negative and multiply it through. Rewrite anything that's in front of the negative that you're distributing. Negative times 10 is negative 10. Negative times 6i is plus 6i. Combining up our real parts, so I'll circle those in red. Negative 3, negative 10 is a negative 13. And combining up our imaginary parts, I'll go ahead and circle those in blue. Positive 5i, positive 6i gets us a total of 11i. All right, just two more. Again, I've got one of these negative situations. I'm going to make sure I distribute it to everything inside the parentheses, rewriting the other terms. We have 13. Negative times 2 is minus 2. Negative times 7i is minus 7i. And this negative has nothing to do with this here. We're not distributing to this piece. It just moves down. Now we want to go ahead and combine up our number part. So we have positive 13 and a negative 2. That's going to leave us with a positive 11. Then we have, for our imaginary parts, negative 7i, positive 5i. Those guys are going to combine up. We have more negatives, so it's going to be minus 2i. One last problem here. Again, we got to distribute that negative through. It's going to be 13 minus 5 plus I, because a negative times a negative is a positive. Bring down that minus 4i. We will combine up the real parts. That's just the numbers. 13 minus 5 is going to leave you with 8. And then combining up the imaginary parts, I and minus 4i gets us a negative 3i. And with that, we're done with adding and subtracting complex numbers. See you next time for multiplying and dividing.